Well, hello there. I'm KP the Math G here. Give me just a second to start this. Get to my what do you call it? Calculator. Yeah, I've got a calculator on my phone, so I ask you to bear with me. All right, let's do this. This is the 2026 free response number 2. The first 2 questions require a calculator, so that's why I've got my calculator out. And so far I don't have anything on it, so I'm going to put everything in from scratch so that we'll know exactly what to do here. Now let's take a look at this very carefully. F at x, that function in green, is 1.43 to the x power plus 0.57. If this is raised to the first power, this equals 2. So that's what that is right there, and that's the green one there. It's not drawn to scale. It should be dipping down a little bit and then coming on up. Anyway, neither one of these are really drawn to scale, but being that I just have just a little bit of board left, I have to draw it a little smaller than I'd like to. Okay, but anyway. And then the blue one is a function. It's a rational function, isn't it? 14x plus 12 over x plus 12. And then, of course, we see that there are 2 places of intersection, 1, 2, and A, B, which we will find out what A, B is probably in another video. But let's find out what this part A is, and I don't know if we're going to have time. We may do parts A and B, okay? And let's look at this. And this is pretty much what you're going to get if you get a problem like this on a free response question. It's a very good, thorough free response question, may I add. So let's look at it. Part A, region R is bounded by x, the x and y axis, or let's just say axes, and x equals 1. Now x equals 1 is here. R is that region that's not colored in at all, okay? It is bounded by, as a matter of fact, it is also bounded by this curve here. And I don't know if I put that down. And so, yeah, the graph of G is here. The graph of G is in blue. The graph of F is in green. So the blue, x equals 1, the x-axis and the y-axis is the region of R. Alright, so really and truly, we're not even concerned ourselves, and that's what you got to be able to do when you're looking at this. I had to study it just a little bit, but not for long. Well, I've been teaching for a long time, but still, even I have to study something. And, you just can't just look at something and say, oh, do that. And sometimes you can, sometimes you can't. Sometimes you need to look at something a little while. So, enough of that. Well, let's go ahead and take a look at it. The blue curve is G. So we got to look at that height there. The height is G. Alright, and so we're taking what we call a partition. Let me erase the R. We know that's region R. And we're looking at this partition right here is what we're doing. Now we call it isovinterval here. We got a little, okay, like that. Alright, we got something looking something like that. Okay. And that height right there, is Y. Well, there's 2 Y's here, other than the Y-axis, but there's 2 others. There's this Y that's green right here, and then there's Y right here that's blue, but this isovinterval stops on the blue one, doesn't it? Okay, and so we're integrating, so we have to know that too. So because it says find the area of region R. Okay, so anytime we're asked to find the area, first of all, we are going to be looking at an interval. This little isobinterval could move all the way from 0 all the way to 1. No further than that. So from 0 to 1. Alright, and then we are looking at this height over here. Alright, so that is going to be the blue function, which is this one here. So actually I'm just going to, instead of putting all of this in here, I'm just going to put g at x right here, g at x dx. And really, if you put that down, you're going to probably get a point for that. Alright, area is you know, you've got your length, which is y. Alright, and you got your width, which is dx, or delta x, which turns into dx, right? So length times width. Okay, and so that's what you got to remember on area. It's length times width. Okay, so that's what we're talking about. And so what we're doing is we're taking several little isobintervals and we're summing them up. And that's what that really means. It's a summation of all those, and those little isobintervals get so small they just become right at being straight lines, huh? You can almost just color it in. So that's what we're doing here. And it is from 0 to 1. It is not from 0 to 2. We do not go that way. We're going this way. Alright? Alright, so let's see here. I've got to put this in my calculator. And the way that we do this is we go to y equals. Alright, so what we have here is y equals. Okay? And so you have a little thing on your calculator that says that. You hit that and you put this in your calculator. So I'm going to do that right now. 14x plus 12, okay, and then divided by x plus 12. Let's see, where is it? X plus 12. Okay. Alright, and I have that in there. So once I put it into y0, I've got a y0 on mine. So I've got a y of 0, and I put all of this g at x in there. So I just simply put down, and I use parentheses, just like that. And then I just kept going with the divider. You can put it like this if you want to. Then you wouldn't need the parentheses if you had it like that. And then, of course, x plus 12 like that. Again, you can use the parentheses, or you don't have to use the parentheses. Either way will work just fine. Okay, so now once you put that in there, then I just got to kind of second quit. And then I go to math. Okay, so math is my next that I do. Alright, math. That's my next function key that I press. I turn on some air, y'all. Usually there. Alright, a little bit warm in here. Alright, so then once I do that, then I scroll down to, it's called F-I-N-T. F-N-I-N-T. And that's going to give me this symbol. It looks like this, just like this. So far nothing's in there. So I'm just going to show you how to put those in. Alright. This little symbol comes up, and you have this box. You have this little box up here. You have this for the function, and then of course d at x, they put that x in kind of like that, just like that. That's what it looks like. Alright, so I'm going to just punch in right here. I just put my finger on mine and put the 0 in there. Alright, that's my limits of integration. And then I put this up here and put a 1 right there, and that puts it up in here. And then to get to the y0, I just simply go, I hit alpha. Some calculators are a little different. My y bar is green, my alpha is green. Okay, the key is green. My y bar is green. I do want to get, that's what you want to do, is get the y bar, and then you just simply punch in y0. Whoops. And let's see, hold on. I got to get it in the right place there. So let's do it again. Alpha, y bar. Oh, I'm still got to do that. Okay, now you got to get it in position again. So for the third time, now y0. There it is. And now once I do that, I just hit enter, and I get, so this y0 goes right here, and now I have this function in here, and it's taking the antiderivative of this function right here. Okay, so that's going to be equal to about 1.513. Now remember, in AP calculus, we go out to 3 decimal places here, tenths, hundredths, thousandths, and since this other 3, you can put another 3 here if you want to. You can put more, you just don't want to put less. Alright, and so that is the area of this. Now, if they had units, you would put like feet, you would say square feet, or inches, square inches, and so on. But they don't have anything, so you don't have to put any kind of units. As a matter of fact, you probably don't even have to say square units. So that's really how you go about doing part A. Okay? I'm going to try to go ahead and do part B. Maybe we'll have a little time on that. Let's go ahead and do that. I think I'll go ahead with part B. We're not going to do part C and D. They take a little time, and I'd like to have a little time to show you how to do that. Let's just look at part B here. And this has to do with a cross-section type problem. And so this is how we do the cross-section. And I'm just going to kind of look at part B this way. Part B. So bear with me just for a moment. Okay. It says region R, described in part A, is the base of the solid. Alright, this region R right here is the base of the solid. Okay. For this solid, each cross section perpendicular to the x-axis is a rectangle whose height is one-third times the length. So the height, this is a cross section. Well, let's put that word, that cross section. Sorry, cross section. Okay. And anytime you see that, you're just going to do this. So your height, what's the height? Well, the height is y. That's the height. And we're still looking at the blue curve. So the height is just this. So the height is g at x. So the height is equal to 1/3 the base. Alright, 1/3 the base. And alright, so it says that so we got the base in region R. So the base is actually g at x as well. So 1/3 of g at x. Alright. Alright, so that's really how you go about doing that. If it were square, you wouldn't have 1 that's 1/3 the size of another. You just have g at x times g at x. Okay, so what you have here is the integral. I don't think we even have to set it up. Right, but do not evaluate an integral expression that gives the volume of the solid. So actually what we do here then is it's 1/3, put the 1/3 on the outside. We're still going from 0 to 1. Alright, g at x and times 1/3 of g at x dx. There it is right there. Now g at x times g at x is g squared at x, so we can do that. Ooh. Well, I could have done it. Let's see if I can. Let's see, I don't know. I'll put it over here. So it's actually from 1 to 3, 1/3 on the outside. Alright. 1/3 g at x times g at x is g squared at x, or g at x. You can just do this squared dx, and that'll work right there. And you don't forget from 0 to 1. There it is right there. Okay, and that's all you have to do there. Alright, so that's really basically all you have on the first two. The first one, you just have to kind of put that into, I put it into y sub 0. Some of you may start off with y sub 1, where you do it that way. You put it in whatever the first one is and learn how to retrieve that when you need it. It does come in handy. Okay, and so everything looks good right here. Okay. Alright, so KP the Math G getting ready to sign off. Ladies and gentlemen, have a great, before I stop, I just want to say, please, if you have not subscribed, please do so. If you don't want to subscribe, okay, that's alright. If you want to, if you like to hit that like button, please do so. You see me smiling every time I do that. I say that every time, don't I? Okay, and then also, if you'd like to make a comment, please do so. I love comments. That kind of helps me. But I'm really here to help you. Alright, so ladies and gentlemen, KP the Math G signing off. Have a great, great day.